Today we are going into part 2 of building our to-do list on the blockchain, on the Ethereum blockchain, built as a decentralized application, otherwise known as a Dapp. We're following Dapp University tutorial. Let's recap what we've already done in the first section. So starting up at the top, we did some review on what the difference is between a Web 2 setup versus a Web 3 application built on top of the blockchain. We then installed Ganache, which we have running over here. It's our local blockchain environment that comes pre-built with 10 Ethereum accounts every time we quick start, which makes it easy for us to test blockchain applications quickly. We then set up Truffle. Truffle we have installed in the CLI, so that we can do things like initialize a new blockchain project, a new Ethereum project. We can migrate, which deploys all of our smart contracts. We can run console, which allows us to make queries directly to and from our blockchain. And we built, and I think that's everything that we did. Let's keep scrolling. We also installed MetaMask. So we set up MetaMask, which is the wallet of the decentralized web. We set up the project using Truffle init. We installed all of our node packages. We specified our Solidity version. All of that is viewable over here. We set up this package.json file. We implemented our Truffle config with our local Ganache server. And we also started our to-do list smart contract with a public task variable initialized at 0. Let's see if we can recap what we did yesterday. So the first thing I'm going to do is I'm going to say truffle build, and that's going to take all of the it says no configuration found for truffle build. I thought we did truffle build. Let's review. I apparently forgot some stuff. Truffle compile. We want to compile our smart contracts, not build them. And even that didn't work. Truffle compile is not wanting to work. Am I doing something wrong over here? Truffle config looks like it's good. We've got our contracts. Sudo truffle compile. Nothing. Okay. Let's just try truffle migrate. Okay, we need to add a sudo. We got permission denied. Okay, we've just deployed both of our contracts, so we should see a change in our Ethereum balance. We now have 3 transactions, and now we can go into the Truffle console, and we can interact directly with that blockchain. So we'll make a task app equals, I believe it is await to-do list dot deployed. Now let's log task app dot address, which gives us the address of the smart contract. And then finally let's run task app dot what's the name of our variable? Task count. So now we can run task count as a function, and it gets back that we have 0 for our task count. We don't have any tasks right now. So that is everything. Now we are on to part 2, where we're going to start listing tasks. Now let's start listing out the tasks in the to-do list. Here are all of the steps we'll need to complete the section. 1. Write code to list tasks in the smart contract. 2. List the tasks from the smart contract inside the Truffle console. 3, this one's going to be cool, list the tasks inside of the client-side application, aka inside of our web browser. And then 4, write a test for listing tasks. Let's get started. In order to list the tasks inside the smart contracts, we'll need a way to model a task in Solidity. Solidity allows you to define your own data types called structs. We can model any arbitrary data in this powerful feature. We'll use a struct to model the task for our to-do list with something like this. So we'll have a task with a uint of ID, a string of content, and a bool of completed. Let's get started with that. We'll define a struct called to-do. Oh, it's just called task. Task, that makes sense. Then we have a uint of ID. We have a string of content. And then we have a bool of completed. First, we model the task with the struct keyword followed by the name of the new struct called task. Note this does not represent an instance of a task, but simply the definition of a task struct. The lines contained in the curly braces define the attributes of the task struct. The uint ID, this is a unique identifier for the struct. It will have an ID just like a traditional database record. Note we declare the data type for this identifier as a uint, which stands for unsigned integer. This simply means that it's a non-negative integer, so it has no sign, i.e. a plus or a minus in front of it, implying that it's always positive. We have a string of content. This is the text of the task in the to-do list contained in a string. And then finally a bool of completed. This is a checkbox status of the to-do list, which is either true or false. If it's true, the task will be completed or checked off of the to-do list. Boom. Now that we've modeled the task, we need a place to put all the tasks in the to-do list. We want to put them in storage on the blockchain so that the state of the smart contract will be persistent. We can access the blockchain storage with a state variable, just like we did with task count. We'll create a tasks state variable. It's kind of like a Solidity data structure called a mapping. So we'll create a mapping of a uint, which will be the ID, into a task struct, and it will be public and it'll be tasks. So let's create that mapping. Mapping from uint to task. It'll be public and we'll call it tasks. I think I did that right. I'm going to copy this onto the line below just to make sure. Looks like I added a space that they didn't have, but outside of that, it's looking good. Save that. A mapping in Solidity is a lot like an associative array or a hash in other programming languages. It creates key value pairs that get stored on the blockchain. We'll use a unique ID as the key. The value will be the task itself. This will allow us to look up any task just by the ID. Now let's create a function for creating tasks. This will allow us to add new tasks to the to-do list by default so we can list them out in the console. So we will have the function of create task, a string from memory instead of from storage called content. So in the create task, we just pass in what we want that task to be. We increment the task count, which is a write to the blockchain. And then inside of our tasks mapping, we'll take task count, which has already been incremented, and assign it equal to a new task with the uint ID of task count. The content is what we passed in, and completed will be false, so that way it defaults to unchecked. Let's get started by defining the skeleton, creating a function called create task. Function of create task. We just want to pass in a string from memory of underscore content. In Solidity, we define state variables which are persistent on the blockchain without underscores, and any local variable from memory with an underscore, so that way we can tell the difference between an actual state variable like this content and something that's only contained within the runtime of this create task function. So we now also want to make this function public so that it can be accessed by people outside of our smart contract. Inside of it, the first thing we want to do is increment our task count. So we'll go task count ++. This will change our task count. which when the contract is initially deployed is set to a value of 0. And each time we create a task, it gets incremented by 1. Next, after we do that, we then want to add an item to our mapping of a new task with the info. So inside of our mapping of tasks, at the location of task count, we want to set it equal to a new task with the ID of task count, the content of underscore content, and then the completed of false. Should be everything. Let's explain what the function does. First, we create a function with the function keyword and give it a name of create task. We'll allow the function to accept one argument called content, which will be the text for the task. We specify that this argument will be of string data type and that it will persist in memory. We set the function visibility to public so that it can be called outside the smart contract, like inside of our console or from the client side, for example. Inside the function, we create an ID for the new task. We simply take the existing task count and increment it by 1. And now we create a new task by calling task count content false and passing in the values for the new task. Next, we store the new task on the blockchain by adding it to the tasks mapping like this. We assign it to the mapping. Now, we want to add one task to the to-do list whenever the smart contract is deployed to the blockchain, so that it will have a default task that we can expect in the console. We can do this by calling the create task function inside the smart contract's constructor function like this. Constructor. The constructor function gets executed when the contract is deployed to the blockchain. So we'll create a public constructor function, and then inside of it, we'll just create a task called, in their case, checkout Dapp University, in our case, checkout at Voice First AI. I'm going to put this just below. I'm going to rearrange this a little bit. I'm going to put our public state variables up top. So we've got a task count and a tasks mapping. Then we have a task struct, which I will also put near the top. And then before any of our functions, I'm going to then put our that's all caps, constructor public. And I think this also needs to be defined as it doesn't even need to have the function keyword because the constructor is already predefined. Now let's call our create task function and pass in check out at Voice First AI. That's it. We create the constructor function with the constructor keyword. As you can see above, the function will run only once whenever the contract is deployed to the blockchain. Inside of this function, we've created one default task with the string checkout.dappuniversity.com. Now let's deploy this smart contract to the blockchain. In order to do so, we must deploy a new copy of our code. Remember, smart contract code is immutable, it cannot change. Therefore, we must create a new smart contract anytime we make code changes. Luckily, Truffle provides a shortcut to assist with this. We can rerun the migrations like this. Voila, we now have a new copy of the smart contract on the blockchain. Let's check out the tasks in the console. Okay, so I'm going to type this out so that I can build in the muscle memory. Truffle migrate --reset. Okay, it's not expecting the migrate keyword. Oh, I'm still in my Truffle environment. I need to get out of the console. Now let's try Truffle migrate --reset. Okay, we got permission denied, so I need to run this with admin access using sudo. And we've now deployed our smart contracts to the Ethereum blockchain, our local Ethereum blockchain. Now we want to go into the Truffle console, and then we will start messing around with our to-do list. So let's go into Truffle console. Now that we are in, I'm gonna try to do this without what they did. To do list equals await. We need the await keyword. To do list, which is our contract name, dot deployed. Now we should be able to log to do list and get what it is set to. We did. To do list dot tasks. I believe it's tasks. Tasks, yep. And now we should have a tasks 0. There it is. And I don't think we have a tasks 1. Actually, let's go back to the tutorial. Now we can get the task from the to-do list by calling, actually, did I not save this? Oh, I didn't save it. Whoops. I forgot to save my code, everyone. Okay. Need to redeploy, recompile. Okay. Compilation failed. Expected primary expression. Ah! I forgot a closing quote. We need this to have a closing quote. Boom. Let's get Visual Studio support, which might help us catch some errors when coding Solidity contracts inside of VS Code. Okay, now we've got some color in this file. Alright, let's save. Let's come back over here. Let's try deploying our smart contracts again. Okay, we got compiles, compilations, truffle console. We have a successful deploy. Now let's set to-do list equal to await to-do list dot deployed. Let's log to-do list. Okay, now let's log to-do list dot tasks 0. Wonder why we're not seeing. I guess it's stored in tasks 1. Oh, because we start off our count at 0, and before we create a task, we increment. So there's no task 0, there's only a task 1. Got it. Okay, what's wrong with this? Okay, we have an outdated version of the compiler, but we'll keep moving forward. We already did all this. Yay, you can now inspect the values of this task from the console. We should now also be able to create a new task by saying to-do list.create task hello world. And it looks like it did. Let's now try to get tasks 2, and we can see that it has hello world. If we try to get to-do list 3, it's going to return that it's empty. But if I create another task and say hello world third to-do list item, we can then log it and see that it is now stored on our blockchain. I'm about to run out of battery, so I'm going to, as quickly as I can, plug in my charger. Okay, let's go back to, yay, you can now inspect the values of the console. Now that we've migrated the smart contract to the blockchain, let's create a client-side code to interact with the to-do list smart contract. You'll need to create the following files for the project. We need a bsconfig.json, an index.html, and an app.js. We'll fill the code for all of these files out one by one. we're using Light Server to serve all the project files for the client side. We'll need to tell Light Server where all these files are located. What is Light Server? Light Server is a lightweight development only node server that serves a web app. Once opens it in the browser, refreshes when the code changes, has a fallback. Why? I'm not sure why we're using this instead of React. Maybe in a future tutorial I'll just use React instead of Light Server. But beside the point, let's keep going. Let's add these files. We'll add a bsconfig.json first. New file, bsconfig.json. We've initialized the file. We need an index.js, so I'm going to set up a new folder called src. Inside of it, we want two files. We want an index.html, and then we also want an app.js. We're using Light Server. We'll need to tell Light Server where these files are located. We can only do this by updating the browser sync configuration inside the bsconfig. So we'll paste the configuration. We've got a server with a base directory, src, and then all of our contracts are inside of our build contracts folder. And then we have a vendor route for our node modules. Copy all this, put it inside of our bsconfig.json. Save that. We should be good now for bsconfig. This configuration tells Light Server to expose all the files in the source folder in the build contracts directories to the root of our web server. It also adds an alias for any files inside the node modules directory to appear in the vendor route. This will allow us to pull in any project dependencies like Bootstrap into the client side with the vendor route, which we'll see momentarily. Next, let's fill out our HTML code. This tutorial focuses primarily on blockchain, so I don't want to spend too much time on HTML and CSS. We'll simply paste the HTML code. Alright, so we will take this real quick, HTML and CSS code. We'll change up a couple things. Instead of Dapp University to-do list, we'll say voice first AI to-do list. We've got our head. Everything looks good here. Standard CSS. We've got a loading page while we're getting stuff from the smart contract. Task content goes there. And that looks like everything. Okay. This file scaffolds all the HTML we need. I've commented out the form code, which we'll enable in the later section. The file pulls in all the dependencies for the project, like Bootstrap templating, that will allow us to create nice looking UI elements without having to write too much CSS. It also uses the truffle contract library. I didn't see that. Truffle. Oh, there's the truffle contract library in the Bootstrap files. I saw something about Dapp in here. Ah. Okay. Now let's fill in the JavaScript file. We'll add the code to the app.js. We create an app object with loading and then a load file that loads stuff. We've got a load web3 that creates a web3 provider getting MetaMask. This gets MetaMask. And then we set web3 equal to the current provider. Otherwise, we alert them, please connect MetaMask. Then we get Ethereum. We set web3 for the window equal to the new web3 built on top of Ethereum. We try to enable Ethereum, and then we send a transaction there. Else if window.web3. So if we don't have Ethereum but we have web3, legacy Dapp browsers versus modern Dapp browsers, we initialize the app3 provider again. Then we can access it to send transactions. And then non-Dapp browsers, we need you to have a Dapp browser. Then we'll load the account, We set it equal to whatever account is active, so the 0th account in the accounts array. We load a contract using the truffle library of to-do list, loading to-do list.json. We then set the provider equal to our MetaMask provider, and then we set to-do list equal to the deployed smart contract. We render, so if it's loading, we don't do anything. Then we set loading to true. Inside of account, we load our account info for Ethereum. We render all of our tasks, which I haven't seen that yet, and then we set loading to false. So we render the tasks. We get the task count from our smart contract, and then we iterate over the task count to get each of the tasks. And task content is task 1, and then task completed is task 2, and then new task templates. We then boop 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 boop. Okay, if the task is completed, we add it to the completed task list. Otherwise, we add it to our task list that we still have to do. Then we show the task list, and then we set loading. We pass in a boolean, and then it turns on our loader element and hides our content if we are loading. Otherwise, we hide the loader and we show the content. All right, let's copy all of this. Very simple code, nothing too complex here. It's using jQuery with a very simple JavaScript file. Okay. Let me explain. We've created a new app object that contains all the functions we need to run the JavaScript app. I will explain the important functions here. Also note that I've commented out a few lines which will enable in later sections. Load Web3. Load Web3. So this function is a JavaScript library that allows our client-side application to talk to the blockchain. We configure Web3 here. This is default Web3 configuration specified by MetaMask. Don't worry if you completely understand what's happening. This is a copy and paste implementation that MetaMask suggests. MetaMask get started. So if you look up the MetaMask get started, you will see inside of the MetaMask docs, here's the exact same code. So we check window Ethereum, which is the same thing we are checking here, window.ethereum for modern Dapp browsers. And we even have additional checks for legacy Dapp browsers. Load contract. This is where we will load the smart contract data from the blockchain. We create a JavaScript representation of the smart contract with the truffle contract library. When we load the smart contract data with Web3, this will allow us to list the tasks in our to-do list. Loading the contract retrieves the smart contract. Then in our render tasks method, this is where we actually list the task in the to-do list. Notice that we create a for loop to access each task individually. This is because we can't fetch the entire tasks mapping from the smart contract. We must first determine the task count and fetch each task one by one. This is important. In a mapping, you can't just fetch the entire tasks mapping. You have to first get the task count, and then you can iterate by grabbing each element from that mapping. Now let's start the web server with npm run dev. Let's see if this works. We will exit out of our truffle environment. We'll run npm run dev. It then starts our to-do list server. It's loading. Loading. Still just seeing it load. Let's check out our console. Not seeing any errors here so far. Let's inspect to see if we can find anything. Warning, Web3 is not defined in our app.js line 16. It also says Web3 is not a constructor. So we're doing something wrong here in our code. Inside of our code, we have, what are the lines we get errors on? Truffle contract. This is a bunch of truffle contract issues. I'm not seeing truffle contract anywhere. So let's check down here, app.js line 16. Web3 is not a provider. Okay, let's see what if our tutorial says anything. You successfully loaded the client-side application. Notice that it says loading because we're not logged into the blockchain yet. In order to connect to the blockchain, we need to import one of the accounts from Ganache into MetaMask. You can watch me set up MetaMask in the video there. Once you've connected MetaMask, you should see all the contract and account data loaded. Let's see if we can connect MetaMask. First thing I should need to do is log into MetaMask. So I'll copy my MetaMask password. I will paste it inside of MetaMask to unlock. Now I don't think we want Mumbai, I think we want an Ethereum. This might not be right. We might need to actually configure it to use our Ganache blockchain, because right now, let's try setting up a custom RPC. We'll call it Ganache. What's the we need a RPC URL. Let's see if we can find that here. I'm having trouble finding it here, so let's check out what he says in the video. We can watch him set it up there.
And now we'll actually use our browser to connect to it with MetaMask. So let's actually do that. I will open up Ganache. Let's actually find the private key here. Show the key. Copy it. All right. We'll go to MetaMask and make sure you've opened this if you haven't already. And what you want to do is connect to the private network, which is localhost 7545, right? So you might see the main Ethereum network first, but you want to change networks to localhost 7545 here. And what you want to do is click this accounts menu. You want to import account, and you want to paste in the private key. Select type, private key, and click paste, and then import. All right, I've already done this step, so I'm not going to do it. So I'll click cancel. Whenever you've imported the account, from Ganache, you want to use this. Make sure you use the first one, because that's the account that we deployed the smart contract.
Let's try this out. So inside of here, let's open up MetaMask. Let's change our network to localhost 8545. Let's see if we connect. Something went wrong. Looks like we're having trouble. I think he said, what was the address he said?
And now we'll actually use our browser to connect to it with MetaMask. So let's actually do that. I will open up Ganache. Let's actually find the private key here. Show the
technical difficulties.
And now we'll actually use our browser to connect to it with MetaMask. So let's actually do that. I will open up Ganache. Let's actually find the private key here. Show the key. Copy it. All right. We'll go to MetaMask and make sure you've opened this if you haven't already. And what you want to do is connect to the
Gonna try this again. We want a private network, so I'm gonna get, we'll call this Ganache. The URL is right here. The chain ID, I believe it's this. I don't know about any of that, so let's save it. Try 1337. We'll try 1337. Oh, so it's already being used by the 8545 network. Well, why don't we check that one out? Why isn't it connecting? See, we're trying to connect to 8545. Let's try this. But it's saying it's already being used. That's what I'm not understanding. Okay, it looks like we're connected. Now we will import an account and we'll paste our private key. Okay, so now we have successfully signed into Ganache. We have loaded our account, but it says we're not connected. I want to connect it. Okay, it says we're connected now. Let's try refreshing. Still not seeing anything. I see my ETH, so we've loaded our ETH in from our Ganache wallet, but I'm not seeing it displayed here.
Private network, which is localhost 7545, right? So you might see the main Ethereum network first, but you want to change networks to localhost 7545 here. And what you want to do is click this accounts menu. You want to import account, and you want to paste in the private key. Select type, private key, and click paste, and then import. All right, I've already done this step, so I'm not going to do it. So I'll click cancel. Whenever you've imported the account, from Ganache, you want to use this. Make sure you use the first one because that's the account that we deployed the smart contract with. Okay. You'll actually be connected with that account to the blockchain, right? So here's your blockchain account, and then you can add it to your wallet in MetaMask to connect to the blockchain with your web browser, and you'll specify the blockchain by picking this local blockchain that we have running with Ganache. Okay. So I'll refresh that. All right, you've got your account connected to the network. Now let's take that account from Ganache, this one right here, and let's show it in our application to prove.
I think we're on the right track right now, so let's keep moving. You should see all the contract and account data loaded. Boom, there's your to-do list. I don't see that, so let's keep following.
Prove that we're actually connected to the blockchain with it. All right. So I'll just say load account like this. Create a load account function. Say load account. This will be async. And I'll say app.account equals web3 each counts 0.
And I thought we already have that. load account. We do.
Okay, so Web3 here was set by load Web3, and it has this ETH object that's going to contain all the accounts, which will be an array. Once you get the first one, which will be the account that we're connected with inside of MetaMask. And inside the load function, I'll say await load account app.load account. Okay, save.
Let's try that inside of our load function. We are already loading account. Let's just make sure that this is happening. Load. Hello world. Okay, doesn't seem like it's ever actually loading, so let's go back here. And then up in our load function, let's just alert before we do anything else. Okay, now we're alerting hello world. So then my question is, why are we having trouble loading Web3? I think we are. We don't like alert. Let's alert web3.current provider. Okay, we got it. And so then we try to create a new Web3 from that. However, I think we're getting an error in our page trying to load it. Reference error, Web3 is not defined on line 16. Yeah, this Web3 is not defined anywhere, so although we're trying to use it, it doesn't actually exist. Let's see if there is, does he have the full code somewhere? Alright, let's check out the source folder, app.js. Where are we getting Web3 from? Where's Web3 being imported from? I'm not seeing it getting imported anywhere inside of this code. I guess we're probably loading it over here in our index.html. Nothing for Web3 over here. Let's see if we have it. No Web3 over here either. So where are we supposed to be getting our Web3 from is my question. We're not importing it. Let's keep watching.
That. And now, inside of the index.html file, you'll see that we have a place for the account here.
Okay. So the error we're getting is that Web3 is not defined anywhere. Web3 is not defined. Let's see what happens if we just search this error. Good coding practice. Alright, so let's add it to our package. we're going to install Web3, which I think makes sense. And then once we install Web3, we will import it into the file that we want it in. So now inside of our code, inside of our app.js, before we call app, let's import Web3. Now let's try running our development server again and see if we fix it. Require is not defined, Web3 is not a constructor. So we can't use require here because I'm not actually sure why. What do we want to do here? Because this code does not look very clean to me. Web3 is not defined. I know it's not. We need to figure out how to import it. Maybe I import it inside of the it's frustrating when the tutorial doesn't work. I know I've built tutorials that end up not working.
This will be the place where we can actually add the.
Personally, I would typically use React. I think it's a much easier language to work with. Web3 CDN import. Let's see if there's a CDN for Web3. This looks like the minified script. So let's try just using this right above our app. Let's see if that does anything. Truffle contract is not defined. Okay, now we've moved past the error and we're now on a truffle contract not being defined on line 53. Line 53. Okay, I guess truffle contract is not defined. Let's see if we can find an answer to this. Okay. Okay. Looks like all of our locally stored packages are not super good, so we're gonna just use CDNs. If I can find a good one that's easy to use. Can I get a... So I think we just got a CDN. Okay, now we just want to switch out the URL with our truffle contract. Let's see what happens now. Require is not defined. I don't think I have require in here. I don't have require anymore. Truffle contract is not defined. I just imported it into my HTML. Maybe I'm using the wrong library. have just gotten it. Let's try that. Truffle contract is still not defined. We could also use require, but I guess we can't use require in the current development environment we're using. You need to add script on HTML. Gonna try to remove this reference to truffle contract and see if that fixes it. App.js line 53. Truffle contract, where's this coming from? It doesn't know where it's coming from. This tutorial is losing me at the client side. We're going to use both of these. Looks like they had some success. Let's see if these work. Hey, there we go. Okay, so now we are reading data from the blockchain. Looks like we can check items, then maybe we can refresh. Okay, we are successfully reading from the blockchain. We've gotten back on track. All right, so let's go back to where we were after all that. Okay, we've now successfully loaded the application, set up MetaMask. We did. We see our contract in the loaded data. Boom. We have our first to-do list. Testing. Now let's write a basic test to ensure the to-do list smart contract works properly. First, let me explain why testing is so important when you're developing smart contracts. We want to ensure that the contracts are bug-free for a few reasons. One, all of the contract on the Ethereum blockchain is immutable. It cannot change. If the contract contains any bugs, we must disable it and deploy a new copy. This new copy will not have the same state as the old contract, and it will have a different address. 2, deploying contract costs gas because it creates a transaction and writes state of the blockchain. This costs ether, and we want to minimize the amount of ether we ever have to pay. 3, if any of our contract functions that write to the blockchain contain bugs, the account who is calling this function could potentially waste ether, and it might not behave the way you expect. So let's create a test file. First, let me check in. How long have we been here? About an hour. I'm going to go ahead and stop the video here. Tomorrow we'll come back for testing. Today we successfully implemented a front end. So we now have a front end that displays the current state of our blockchain. We know that it's associated with our blockchain. I'll do something like this. I'll do a new tab. And then over here, I'm going to run truffle console. Once I'm inside of the truffle console, I'll say task list equals await to-do list dot deployed. Let's log task list. Okay, now let's say task list dot create task of goodbye, see you tomorrow. We've now created a task, so let's refresh this. And it doesn't show it. Okay, now let's say task list dot tasks 1. Okay, so it looks like we are writing to the blockchain, so I'm curious as to why. There it is. Goodbye, see you tomorrow. Okay, and let's, just to test this once more, let's add another one. Find your voice. Send that. We refresh over here. And we don't have it yet. I guess it takes a couple seconds for it to actually get written to the blockchain. Curious, because it's still not there. Interesting. I see it. I just read it from the blockchain. And there it is. It's weird that we have to read it from here in order for it to show up. However, this is information being read from our smart contract on the Ethereum blockchain, which is running locally on Ganache. If you have any questions about today, where we set up our front-end client to communicate with our back-end smart contract, let me know in the comments. Otherwise, make sure you keep finding your voice. This is Sweets, signing off.